Well, hi, welcome to Chapter 11. And Chapter 11 is kind of a good chapter to cover because we've probably seen a lot of times where we have errors a lot and the program blows up and basically we can't do anything else except stop the program, restart it, and try something else. But let's say you're a user and you're using a program that was written by somebody and it blows up. What do? Well, you might try rerunning it, and if you get the same error, as a user, you're probably just going to give up and say it doesn't work. So what we need to do as programmers is we need to be able to capture those errors. Don't stop the run of the program, but capture those errors, display some type of error message, and let the user continue on doing something. Whether you say the program is broke and you basically need to close it, or maybe you can't do this, try this over here, do something, but let the user know that they are able to continue doing something. Whether it says, sorry, we can't continue, you have to close the program. Again, at least the user has the ability to continue on. Now, we've probably seen one of these before. Here we have a bad array. Basically what we're going to try to do is go outside of the array. So if I try to run this, we are going to see some red letters down here, and it's going to come up and say boom. Basically, I believe subscript out of range is probably what we're going to see. Index out of bounds. So basically we tried to go outside of the array. So the array says 1 2 3, so it's 0 1 2, and there we tried to basically go 1, well, it's less than or equal to 3, and basically again outside of the range of that array. So exceptions, what is that? Well, if we look in the book on page 701, here we see we have a hierarchy. So what we have is, now we kind of talked about in the previous chapter is, or previous chapters, is everything is extended from the object class. Everything is. And one of the things we have is this thing called throwable. That is a class. And then outside of that, we have two types of errors. We have what's called an exception, and then we have just a plain old error. And a plain old error, we cannot capture that. That is just basically something we can't capture, so to speak. So basically, maybe the system hiccuped up, or there was some type of downtime with the computer or the network or something. Those are things we just cannot capture. But exceptions we can. And there's two types of exceptions. One's called an I/O exception, and this is a superclass for exceptions that are related to input and output operations. So trying to get into some type of a file, reading a file, so on and so forth. The other one is called a runtime exception, and these are exceptions that result from programming errors, such as the one we just saw a second ago, the index out of bounds, or out of basically trying to go up beyond what the index allows. So that's a runtime exception. We can capture those. And the way we do that is we need to have this exception class in our code somewhere. Okay? And the way we do it is we use what's called a try-catch routine. We say, I want to try something. If there's an error, let's capture it and basically deal with it. Okay? So here we have catch, here's the exception type and the parameter name, and then we have basically some code we want to execute in order to basically get around that guy. Here's an example. Try file. Just going to create a new file and instantiate it with the myfile.txt, and we're going to basically get a scanner input, new file name. If the file is not found, don't blow up the program, but instead display this file not found message to let the user know that file is not found, and give them the opportunity to retype in the file name. Okay? So the exception that we are going to capture is this one called file not found exception, and that is a pre-written exception. We can write our own, but there are quite a bit of exceptions that we can utilize as well. So let's take a look at this open file. So if we take a look, we have got file, so we're creating a file object from the file class. We got our scanner, we got a string called file name, and I say file name, enter the name of the file, and I say try. File equals new file. So this file up here, we're going to try to instantiate it as this new file that we get from the user, and we will try to display then if the file was found, we say the file was found. Else, we're going to capture a file not found exception, and we're going to put that we're going to grab that guy and throw it into the object here. So it's kind of like we instantiated a new exception object, and we're going to call it E. That's kind of the default. And then we say file not found, and then we basically go ahead and say done. So if we go ahead and run this, it's going to come up and say what is the name of the file. I'm going to go ahead and say bad file.txt, and I click OK. Now again, it did not find that, so it didn't blow up and displayed that message, and then basically said we're done. Okay, but if I go ahead and run this and I type in good file.txt and I click OK, that file was found, and we basically get out and we're done with the program. Okay, so now if I did this, I'm going to try commenting these items out. And now let's try running it. And what is the error? What are you barking at? Oh. Well, it basically is forcing us to basically have a try catch. So whenever we deal with files like that, we need to do that. So anyways, you basically get the point is that we can capture errors and basically not blow up the program to the user. Okay, so let's continue on. Let's take a look at the exception message. And this guy basically is going to utilize now every exception class has a method called getMessage. So we can actually get the message from that exception class, and it will display that. So if we look here, we basically are trying to get a file name. Here's our file. We say catch file not found, blah 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 blah. This now look at this. So here's my file not found exception. Now this is pre-written for us. It's part of the exception class. I'm throwing that into an object called E. So I then go ahead and say, now there's basically a couple of parameters for the JOption pane, but I'm going to go ahead and say e.getMessage and display that. So if I go ahead and run this, and I go ahead and type in bad file.txt and click OK, it says bad file.txt, the system cannot find the specified file. So that was pre-made for us. So it's always nice to grab the message that comes with that exception and display it. Now there's all kinds of exceptions: divide by zero, out of bounds, null pointer. There's all kinds of different messages that we can capture and they're available to us, and we have to kind of go into that exception API online and kind of find out which exception we want. Now we're going to see here in a little bit that there is a generic exception that we can use for all basically it's kind of a catch-all. It catches all exceptions. So we can actually put them in the order that we need. So capture this one, this one, this one, this one. And if it doesn't find those, we can actually put that catch-all at the bottom. So here's kind of what's good about, or the good and bad of this, is this one right here catches a file not found exception, but that's all it's going to find. It will not find anything else. So we need to basically, once we cover that, we'll know what's going on there a little bit more. And as you can see, here is another exception we can capture, one called the number format exception. So here we have some type of number formatting we're trying to do. So here we have string A, B, C, D, E, and we have int number, and I say number equals parse int string, and we capture that. So basically it's a conversion error. So if we run this, it says conversion error for input string A, B, C, D, E, and then we basically, that's the message that was supplied to us through the get message. So we're trying to take A, B, C, D, E and convert it to an int, and it won't work. So we basically get that. So again, the program did not blow up. We captured the error, displayed it to the user, and the user could continue on doing something. These are great for when we have the user type in data and that data is incorrect. We basically say that data is incorrect. We then give them back control of the program, allow them to then type in the correct information. So to kind of extend on what I just said just a few seconds ago, is we can capture multiple errors. So here we have a sales report, and here we've got a string, which is the date, the file name. We've got months. We've got double, double, double. We basically have decimal format and decimal dollar, and then I say try. So here's my try statement, and here you notice I got a whole lot of code inside there. I say file equals new file, scanner input the new scanner file, and then I say while the input file has next, 1 month equals that, total sales equals that, and then we go ahead and increase the months by 1, and basically step through that whole loop. And then I go ahead and close the file. And then I say average sales equals total sales divided by month, and then I go ahead and display that in J option panes. But if any error happens within this entire try statement, I can catch a file not found exception, or I can also catch an input mismatch exception. So basically what we're saying is non-numeric data found in this file. Okay, and then we go ahead and exit. So look at that. I can either catch one or the other or both. So I go ahead and run this, and it goes ahead and it found the file, so that was good. We go ahead and run it, and life is good. So not too bad. But what if we So I went into the sales data.txt and I changed this to a 6a right here. So now if we run this again, watch what happens. This is non-numeric data found in this file. So it found the file and tried to run everything, but then it found non-numeric data, so that's basically kind of a really, really good thing there.